All right, so 5.5a, multiple angle formulas. So now we're going to be talking about double angle formulas today. So we're going to be using the second thing kind of on your reference sheet. And we notice here we have sine of 2u, cosine of 2u, tangent of 2u. And so this is a double angle because there's two of the angles. And we have to use these formulas to get to where they're singular angles. All right. So if it's sine of 2u, we can use this one. If it's cosine of 2u, a lot of the times we're going to use this top equation, but sometimes we can use these bottom two equations because this one puts it all in terms of cosine. And then this one puts it everything in terms of sine. All right, so sometimes we need that to work with them. Now, I never use this tangent one. Why not? It's sine over cosine. All right, so let's look at this first one. We have 2 cosine x plus sine of 2x is equal to 0. And I need to solve for when that's a solution. All right. So what's wrong with it right now? There's a double angle. Exactly. There's a 2x and there's an x. All right. Remember when there was like a squared and a singular as well? Like a cosine squared and a cosine? Or a sine squared and a cosine? I could change the sine squared using Pythagorean identities, right? Well, I can't change this cosine x. However, I can change the sine of 2x. Are you following me? So sine of 2x is actually the same thing as 2 sine x cosine x. All right? All we're doing is replacing this with that. And then I still have plus 2 cosine x going on over here is equal to 0. And now we're ready to kind of start solving this equation. Well, what could we factor out? We can factor more than just a cosine. We can factor out a 2 cosine. All right, it's not really going to make too much of a difference. 2. All right. And then what are we left with? 1 plus sine x. And so now we're going to use the zero product property. We're going to set that equal to 0 and that equal to 0. So I set 2 cosine x is equal to 0. And I set 1 plus sine x is equal to 0. Well, I divide by 2, so cosine x is equal to 0. So when is cosine x equal to 0? A pi over 2. When else? And a 3 pi over 2. All right. Now, does this one give me any domain restrictions? No, it doesn't. So what should we add to these? Plus 2 n pi's. All right. All right, let's look at this next one. I have 1 plus sine x is equal to 0. So this is really when sine x is equal to -1. So when does sine give me -1? At 3 pi over 2. So x is equal to 3 pi over 2. Again, it doesn't have any domain restrictions, so I say plus 2 n pi. Now, do I need all of these as my solutions? I don't. I could actually write it in a singular line. How could I actually write this? Pi over 2 plus what? N pi. And why do we just have n pi? Because it covers it, exactly. Okay? Even though the period of sine and cosine is 2 pi, all right, I could cover it by just saying n pi. All right? Are you following? All right. Do this one. The first thing we need to do is we need to change this. We need to change that to 2 sine x cosine x. And then we still have minus sine x is equal to 0. And then what could we do? We could factor out what? We could factor out just the sine x. And then what are we left with? 2 cosine x minus 1 is equal to 0. So then we're going to use the zero product property. So I get sine x is equal to 0. And then I get cosine x is equal to 1/2. And so when does sine equal 0? At 0 and pi. Now, can I actually include 2 pi on this one? No, I cannot actually include 2 pi because it's not on my interval. All right? It has a parenthesis, which means it does not actually include 2 pi. All right, so this next one I have cosine x is equal to 1/2. So when does that occur? Pi over 3 and 5 pi over 3. All right. So if it's free response, I'm cool with it just like that. However, if it's multiple choice, which some of this test is, like half of this test is multiple choice, they're going to put it in order. They're going to say 0, pi over 3, pi, and 5 pi over 3 as your answers. Okay, they will be putting them in numerical order. Okay? We're going to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. And so we've dealt with these since chapter 4, except now we're just using double angle formulas for them. So I have cosine of theta equals 5/13, and then I'm given this constraint, or a domain restriction in this case. I have 3 pi over 2 to 2 pi. So what does that constraint tell me? I'm drawing that thing in the fourth quadrant. That's what it's telling me. All right, so I'm drawing this in the fourth quadrant. All right. And what's cosine? Adjacent over hypotenuse. So my adjacent is 5. My hypotenuse is 13. So what's my other side? 12. However, is it 12? No, it's actually negative 12. Why is it negative? Because it goes down. It goes down. That's why it's negative. And so once we have that, we're pretty much set to go. So now I need to find sine of 2 theta. And so all I need to do is kind of use my little formula. So sine of 2 theta is just 2 sine theta cosine theta. All right. So 2 times, what is the sine of theta? Now I'm going to use my little triangle. So what's the sine of that triangle? Negative 12 over 13. And then what's the cosine of that triangle? 5 over 13. All right. And so now I just have to do a little bit of math. 2 times 5 is 10. 10 times negative 12 is negative 120 over 13 times 13 is 169. All right. So sine of 2 theta is negative 120 over 169. All right. And then cosine of 2 theta. Now we have lots of options to use here. I would highly suggest when you do it with these triangles to use this top one. The top one is going to give you common denominators right away. Do you have to use the top equation? You don't. All right. You could use either anything. All right. However, the top one will play the nicest on these. Does anybody want to use anything other than the top one? I don't mind. You want to use the top one. All right. You're going to believe me. Okay. So now I have cosine squared theta minus sine squared theta. So what's the cosine of my theta? 5 over 13, and then I'm going to square it. And then what's the sine of my theta? Negative 12 over 13, and I'm going to square it. So 5 over 13 squared is 25 over 169. And then minus, what is negative 12 over 13 quantity squared? 144 over 169. All right. And so we have to do 25 minus 144, which is negative 119 over 169. All right, so cosine of 2 theta is negative 119 over 169. All right. Now, the nice thing about that when you're working with these triangles is you see how it gives us perfect common denominators when we do it that way? All right, that's why it's kind of the easiest one when we do it with the triangles. All right, and then tangent of 2 theta. Am I going to use that formula? I'm not going to use it. All right, could you use it? Ain't nobody got time for that. So what would I do? Sine over cosine. So I end up with 120 over 119. Now, we could say negative, negative, but what happens with a negative, negative? It becomes positive. All right, try this one. All right, so on this one, this constraint tells me it's where? In the fourth quadrant. So then we have sine. Sine is opposite over hypotenuse. Why is it a negative 3? Goes down. So what's my other side? 4. All right, and so now we have sine of 2u. And so I would recommend you rewrite that. However, for the sake of time, I'm just not. All right, so now I have 2 times. What's the sine of u on this one? Negative 3 over 5. And then the cosine of u would end up being 4 over 5. All right, so then we got to do a little bit of math, and what do we get? All right, pretty good. All right, and then cosine of 2u. All right, so did anybody use anything other than the top one? All right, so we're just going to use the top one. So then we have cosine, which is 4 over 5, and then I'm going to square it, minus negative 3 over 5, and I'm going to square it. So 4 over 5 squared is 16 over 25 minus 9 over 25, and we end up with 7/25. All right, and then tangent of 2u. You could use that formula, however, that's way too much work. What's the answer? Negative 24 over 7. We just put sine over cosine. Pretty good? All right. You write that down? And then I'd like you to just look at with me with 23. All right, real quick. I'm not going to do these with you, but you guys can figure them out. Now, secant of 2 theta. Which one would you look at? You'd look at cosine of 2 theta. So you just do cosine of 2 theta, which you have to do in this one anyway. But what would you do to find secant of 2 theta? You just do what? You flip it. All right? And same thing with cosecant of 2 theta. You'd actually do what? Sine of 2 theta. And then you do what? You flip it. All right? Now, look at 23. On 23, you have cosine of 2x minus cosine x is equal to 0. And so, again, you have cosine of 2x, and you just have a regular cosine. You got to fix one of them. So you can use your double angle formula for the cosine of 2x. Now, you have how many options? You got 3 options. Which one would I suggest you use? I would not suggest you use the top one. The second one. I'd use the second one. Why would I use the second one here? Because everything's in terms of cosine now. All right, so on 23, I would actually replace cosine of 2x with the 2 cosine squared x minus 1. Okay, so I would actually replace that, and then you can factor. Okay?